So, let's imagine a beam of light being reflected between two mirrors. Let's replicate this setup so we have another beam of light being reflected between another set of mirrors, but this time, the mirrors are moving close to the speed of light. We can see in the moving set of mirrors that the beam of light is moving a greater distance. Now, let's put a couple of people into this scenario. Meet Alex. He sits inside the moving set of mirrors, and Bill sits inside the stationary set of mirrors. The speed of light must be the same for both Alex and Bill, and their light beams must hit the bottom mirror after the same amount of time has passed. But, as Alex's light beam is covering a longer distance, how is that possible? Well, the only way for that to work is if time for Alex slows down. Look at the clock hand. Notice how Alex's clock hand is moving much more slowly compared to Bill's. Time for Alex has slowed, which allows his light beam to travel a greater distance. Look at it this way. Speed equals distance divided by time. As Alex's distance is more, the value of his time must be more. Or rather, Alex's 1 minute actually turns out to be longer than Bill's 1 minute when you compare the two. Time has slowed down for Alex. This is called time dilation. This is quite a hard concept to grasp because it seems to go against what we experience on a practical level. But to understand the theory of relativity, you must stop thinking of time as a fixed unit for everyone. Time is relative.
In 1913, Sagnac carried out a simple experiment of passing light in opposite directions around a table and recombining them. This produced interference fringes. He then rotated the whole table at 2 revolutions per second and found that the fringes changed. This result has very significant implications in science. It works as follows. A beam of light leaves the light source at the bottom left-hand corner and is split into 2 different beams, which we have coloured red and blue just to distinguish them. They travel round the circuit in opposite directions until they eventually reach the splitter, which also recombines them. There, they then go on to the photographic plate, where they have interference fringes. In this simplified version, we see that the beam is split into 2, the red and the blue again, and they go round the circuit and are recombined at the splitter and recombining prism, so that they again produce the fringes on the photographic plate. Now let us rotate the table. Before we do so, there is the very important subject of the effect of the ether. The Michelson-Morley experiment failed to detect the 30 kilometers per second motion of the Earth through the ether. So to overcome this problem, Einstein simply abolished the ether in his relativity theory. The very significant result of the Sagnac experiment was that it proved that the ether existed. Let us see how it did this. It is a fundamental feature of relativity that it claims that as there is no ether, light travels away from a source at the same speed relative to the source, whether the source is moving or not. Thus, whether the table is turning or not, the fringe patterns should stay the same. But if the ether exists, once the light has left the source, the speed of the light is controlled by the ether, independent of the speed of the table, mirrors, etc., as we see here. So let us see what happens when we rotate the table. Here, the light is split, and the red and blue lights go in opposite directions. But notice that the left-hand mirror has moved around in such a direction that the distance the red light has to travel is further. Now in relativity, the same time should be taken because the splitter is also moving and the distance between them is the same. But now imagine that the ether exists and the speed of the light is controlled by the stationary ether. Imagine the ether like a thick treacle that limits how fast the light can travel, independent of the motion of the light source, the splitter, or the mirrors. The result is that the red light takes longer to reach the left-hand mirror. Similarly, the right-hand mirror is coming towards the blue light, so it reaches the mirror quicker. After they change ends, the red light again takes longer to reach the recombiner, whilst the blue light gets there quicker again. So they reach the photographic plate with a delay between them, and this changes the fringe pattern. In fact, Sagnac, using the speed of the rotation of the table, calculated how much the fringes should change, and found that they did change by just that amount. The crucial feature of this experiment is that it demonstrates that the ether does exist, which demolishes relativity. How does the scientific establishment deal with this result? By muddying the waters with scientific gobbledygook. Wikipedia says, in the above discussion, the rotation mentioned is a rotation with respect to an inertial reference frame. Since this experiment does not involve a relativistic velocity, the same wording is valid both in the context of classical electrodynamics and special relativity. How on earth can it be valid in both theories? It clearly proves that the ether exists because the speed of the light is controlled by the ether, independent of the rotating table and mirrors. This experiment is never taught to university science students. They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else.
There is no such thing as absolute motion or absolute rest. Objects move relative to each other. For example, look at the truck with two kids playing catch. The truck is moving at a constant speed of 50 miles per hour, but as the kids are also moving with it at 50 miles per hour, they could easily think that they are standing still. When the children throw the ball at 10 miles per hour, they observe that the ball they have thrown is moving at 10 miles per hour. But their little brother, who is not on the truck and is standing still, has observed that the ball has moved at 60 miles per hour. He has added both the speed of the truck and the speed of the ball together. But is the little brother really standing still? No. The Earth is constantly in motion, the Sun is constantly in motion, and the galaxy is constantly in motion. Therefore, nothing is ever at absolute rest or absolute motion. Things just move relative to each other.
It is claimed, due to Earth's rotation, that water draining in sinks and toilets in the northern hemisphere spins clockwise, whilst upside down in the southern hemisphere it spins counterclockwise. There are also claims that snipers and ballistic calculations have to establish a control, when this is clearly not the case. Just as with Foucault's pendulum, while they blatantly claim it rotates with Earth's alleged spin, in reality spins in either direction without discrimination, neither do sinks nor toilets drain consistently as claimed by the so-called Coriolis effect, with many sinks having been found to drain both ways, simply depending on the shape of the basin and the angle of the water's entry, not from the alleged rotation of the Earth. Hurricanes and other cyclonic storms also do not follow the alleged Coriolis effect, with global wind patterns appearing to blow haphazardly around the ball. But when looking at the wind patterns on the azimuthal equidistant map projection, the weather patterns are found to consistently spin counterclockwise around the flat Earth, paralleling the rotation of the Sun, Moon, and planets against the stellar mobile above. The only ready explanation for this link between these two seemingly unrelated phenomena is in the ancient philosophical concept that the universe is manifest within an ocean of ether, and everything is interconnected.
They will also say that if a sniper is, is trying to hit something at a great distance, a couple of miles away, they have to take into consideration the spinning of the Earth, because they say that as the bullet leaves the muzzle of the gun, it's now independent of the rotation of the Earth. So, the Earth will spin away from where the bullet, and you have to take that into account. They say that about artillery shells as well. But it's not true. If that was true, a sniper would have to spend ages and ages calculating how to make that shot, and they don't. They literally take into consideration the wind, and you know, the elevation, and they don't take the Coriolis effect into consideration at all. Also planes, if that works for bullets, if bullets, as soon as they leave the Earth, they're now independent of the spin, then why doesn't it work for planes? Yeah, there's a video on YouTube that actually tries to explain that the Coriolis effect works by using the example of a paper plane. You have to throw it. If you throw it north, the Earth will spin and the plane will land sort of you know, east. But if you take the idea of a real plane, you know, a plane would have to aim north to go east in that case. But that's not what happens. And if that was the case as well, planes would have to land on runways that are moving, and that would be impossible. But how is it that you can take a flight from London to New York and it will take exactly the same time as a flight from New York to London? Yeah, one's with the spin of the planet and the other one's against it. So it doesn't make sense. They'll say that the whole atmosphere is moving, yeah, with the planet, but that doesn't make sense either, because you know, the atmosphere, say it's that thick, the top layer of the atmosphere will be moving slow, and as further you get in, will be moving faster. So you know, how, if everything is moving like that, how do you get a light breeze that blows against the spin of